let's look at some concepts of basic transport. So with our basic transport, we're going to be looking at fluid. We have intracellular fluid and extracellular fluid. With extracellular fluid, the main cation is sodium. Cations are your positive charge and anions are your negative charge. The main anion in extracellular fluid is your chloride, so sodium and chloride go together. The main buffering system in extracellular fluid is bicarbonate. You recall in extracellular fluid, the main buffering is bicarbonate carbonic acid pathway. With intracellular fluid, the main cation is potassium. Potassium likes to be inside cells, whereas sodium likes to be outside cells. And our main buffer inside cells are your proteins. So with diffusion, compounds are moving from high concentration to low concentration. We have simple diffusion and facilitated diffusion. With simple diffusion, if we have lipid solubles, so lipid soluble compounds will move by passive diffusion. They're able to readily diffuse through the lipid bilayer without the aid of anything. And then we have water soluble compounds can move through the lipid bilayer, but in some instances where we have like waters moving through channels, those channels are known as aquaporin. Or we have some gates. We have types of gates that are located within cells. We have voltage gated, which is going to be dependent on the charge of the cell to open up that gate or to close that gate. That would be like your sodium-potassium channels. And then there's also ligand gated, which is going to be controlled by the concentration of a particular type of chemical. An example of that would be like acetylcholine. Acetylcholine is released and it can cause opening or closing of certain channels to release other chemical compounds. Then with diffusion, if it requires a carrier protein, it's known as facilitated. Facilitated diffusion means we have to have some help to get that compound absorbed or transported. So our protein is going to facilitate movement of a particular particle. Whenever we have proteins that are involved, there's only so many proteins that we make, so those proteins can become easily saturated. So it's usually going to be the limiting factor with how much we're able to absorb or move across a membrane that requires facilitated diffusion is how much of that particular protein that you have. And lastly, we have osmosis. With osmosis, we're looking at movement of liquid through a semi-permeable membrane where the water is able to move, but nothing else within the solution is able to move through the membrane. The water is going to move from a high concentration of water, low concentration of nutrients, but high concentration of water, to a low concentration of water. So that means we actually have a really highly concentrated electrolyte solution on one side, and our water particle is going to move to that high electrolyte concentration where we have less water available to try to equilibrate out the concentrations. In order to prevent osmosis from occurring, this is known as your osmotic pressure. And this does have an influence on the volume of a cell. If there's no net change in the volume, that solution is known to be isotonic. When we have movement of water into the cell, that's usually a hypotonic solution, where we have an increase in cell volume, which means you have a lot more water on the outside of the cell that's moving to the inside. And we have movement of water out of the cell, which means you're usually in a solution that's hypertonic. So you have a higher concentration of electrolytes outside of the cell, and water is going to move from the cell to help try to equilibrate that out. That's going to cause a decrease in the cell volume. Okay, that concludes basic transport.